My name is Jonathan McGowan. This is going to be part 3 of the third assignment for EAS3810C. In this portion of the assignment, we're going to be a continuation of part 2. We're going to be using XFLR5 to, oops, let me type that in correctly. We're going to be using XFLR5 in order to add flaps to flaps that go up and down from 15 degrees to 30 degrees and then negative 15 degrees to 30 degrees, just to analyze the lift slope curve. So let's see here. We're going to go to XFoil design. We'll just do a NACA. We'll do a NACA 4410 again. This will be 4410. And then we're going to do 220 panel nodes. Click OK. Now, in order to add flaps, all we're going to go to is foil and then set flap. Once you're here, we just want to do trailing edge flap. So we're going to go here. It starts your flap at 80% of the chord length, but we're going to change this to 75%. Just like that. And we're going to change, noticing that positive angle is downwards. So first we're going to start off with 15 degrees downwards, like this. Once you're done, you click apply, click OK, and then rewrite over your original airfoil. It's hard to see here, but the flap is actually, it's angled down 15 degrees here at 75% of the chord length. So similar to the other part 2 of this assignment, all you're going to do is go to direct foil analysis. And because we're just trying to find the lift slope curve of this airfoil, we really only have to analyze from approximately -5 to 15 degrees, because that's kind of where the slope starts to curve outwards, and that's where we get our kind of our stall. So we're going to go to analysis, define analysis, go to 375. Actually, we're going to go a million on this one, or 125, 1,250,000. Excuse me. Beautiful, just like that. Click OK. And we're going to go from, again, -5 to 15 with increments of 0.05. Again, we're just doing these small increments to have a better convergence. And if there is any issues, again, we can find the local slope between the points that are uncertain and then kind of fill in along that trend line. So here we're going to click Analyze. Let that run for a couple seconds. And as you can see in the background, it is starting to create our lift slope curve. Seems that we have a little bit of a weird thing happening right here. So in general, it seems like this lift curve slope is pretty consistent. So we might try to, in the analysis section, try to connect these two lines for a little bit smoother by just using the slope again of this line and kind of relating it to here. Because in general, from what I've noticed, is that this slope initially starts out to be this slope, but then it kind of verges off and does its own thing, which again isn't really like how the lift slope curve is supposed to be. It's supposed to be linear all the way up. But again, we can fix that in the analysis section. So again, this is for the 15 degree. So you also want to do this for the 30 degree, and I'm going to show you the result from doing the -15 degree, which makes the flap go upwards rather than downwards. So really quickly, we're just going to go to set flap, edit that. We're going to change this to -15. Click OK. As you can see, our flap is now angled upwards. We're going to then go to File, XFoil Direct Analysis, define an analysis, 1,250,000 Reynolds number, and we're going to do the same increments again. Trying to see if we can get anything on the lift curve slope here. There we go. It's taking a second. It is starting to go there. It's just taking a minute. As you can see, we have many more converged points. And this is just because, again, we did those small increments of 0.05 degrees for the angle of attack. So from here, we can then take our data, click here, go to current graph and export graph. You would do this for all these different situations and then put them into Word. So I'm going to quickly show my results for this. Project 3 bonus. After taking all of our data from the graphs in XFLR5, you see we have 15 degrees, 30 degrees, negative 15 degrees, negative 30 degrees, and 0 degrees. And again, this is for a Reynolds number of 1,250,000. Here we have our lift slope curves. As you can see, I managed to adjust the values slightly for those discontinuities and get kind of a more even distribution. It may not be 100% accurate, but given that the upper lift slope curve is should be reflective of the bottom, I kind of considered that as well. Here we have our color codes. As you can see, when we increase our flap angle, we have a little bit higher of a starting lift coefficient, which is expected. And then kind of as we go down to like negative 30 degrees, negative 15 degrees and so forth, you start to see, I believe these two values are actually mixed up. I need to go back and fix that. But as you can see, our lift coefficient decreases quite significantly when we add those upward facing flaps. So that will conclude this portion of the project 3 and the final portion of project 3. My results will be obviously displayed in the project report. Thank you so much for watching.